All right, well, hello everyone. My name is Dave Bader. I'm with Marine Mammal Care Center, and I'm joined today by two fabulous people, Dr. Cynthia Smith and Dr. Forrest Gomez. We're going to talk to us a little bit about, well, their title of their talk is Sustained Maternal Illness and Low Reproductive Success Rate in Barataria Bay Bottlenose Dolphins, Tursiops truncatus, following the Deepwater Horizon oil spill. We are so happy to have the two of these wonderful people join us today for this talk. As always, we want to thank our sponsor for this program, Marathon, for allowing these types of talks to happen, giving us the support at Marine Mammal Care Center to get this work done. Let me introduce them. Cynthia Smith is the Executive Director and Chief Medical Officer for the National Marine Mammal Foundation, headquartered in San Diego, California. She's a DVM with over 20 years of experience in clinical medicine and research aimed at improving the health and welfare of marine mammals. She is applying her expertise to advance veterinary tools and conservation approaches for improving the health of wild populations. And we're also joined by Forrest Gomez, who is a marine mammal veterinarian and serves as the Director of Medicine for the National Marine Mammal Foundation in San Diego, California. She works to advance marine mammal clinical care and research for the application to at-risk populations globally. I've had the wonderful privilege to get a chance to meet these two wonderful people and work with them over the past few years. And I'm really excited to share with all of you the wonderful work that the National Marine Mammal Foundation does, and in particular, Forrest and Cynthia and all the great stuff they're going to be telling you about today. So without further ado, I want to toss it over to you guys. A little bit of logistics. If you guys have any questions or anything like that, I'm going to be managing the chat, but we're going to save up our questions for the end. So if you have something that's super pressing, we'll store them up, and at the end of the lecture, we'll give you a chance to do a little bit of Q&A. All right, Forrest and Cynthia, take it away.
All right.
Stop sharing.
And I have to start sharing. So let me do that real quick. Let's see. How is that?
Perfect.
Good?
Looks great. Looks great for it.
Well, good evening, everyone. Thank you for taking time out of your night to spend with us. We're really excited to be here. And as Dave already said, he is a good close friend of ours, and so it's fun to be able to come and meet with you and your colleagues as well, Dave. So thank you for the invitation. I was going to introduce ourselves here in this slide, but I don't really need to. You did a fantastic job of talking about who we are, both Cynthia and I. I think the only other thing that I could add is potentially our roles within the response to Deepwater Horizon. Cynthia did serve as the lead veterinarian in the response, looking into the impacts of oil on the health of bottlenose dolphins following the spill. And then I also served in that capacity as a veterinarian, helping with health assessments as well as follow-up research projects over the last decade. And so we're excited to share with you some of our findings from that work. And in particular, tonight, we're going to talk about reproduction. All right. Before we dive in, I do want to give you guys a little background just about who we are, in case you aren't familiar with the National Marine Mammal Foundation. We are a nonprofit and we are in San Diego. We were founded in 2007 and have now grown to close to 130 staff members, and we're made up of a hodgepodge of expertise and different folks, everyone from veterinarians to scientists, conservation medicine experts, research and animal care specialists, educators, the list goes on. We, like I said, our headquarters are in San Diego, but we also have a field office in Charleston, South Carolina, which is where our conservation medicine team is located. And our mission is to improve and protect life for marine mammals, humans, and the ocean. Our story, even though we were established in 2007, our story began many years ago, over 60 years ago, with Dr. Sam Ridgway, the foundation's president, who's often referred to as the father of marine mammal medicine. He began his early in his career applying knowledge gained through research that he was conducting and the clinical care of animals in his care in a managed setting for the conservation of endangered, threatened, and at-risk marine mammals around the world. I love this photo in this picture. Sam, with his broken arm, is on the Yangtze River in China. He was asked to come to help the conservationists, local conservationists that were fighting to save the Yangtze River dolphin. Unfortunately, soon after this photo was taken, the species was declared extinct. This is unfortunately not an uncommon story. Most of us know, probably most of you on the call today know that our planet is in the midst of a human-induced mass extinction event, and 1 million species are at risk in total, and thousands have already vanished literally before our eyes. And despite really good intentions and major investments of time and effort and funds, the rate of extinction has only accelerated. And IUCN, the International Union for Conservation of Nature, has reported that more than 28,000 species are at risk of extinction, including 25% of all mammals. That's really staggering and definitely is constituting a conservation crisis. So at the foundation, in an effort to help do our small part in this fight against this crisis, this extinction crisis, we're aiming to apply our unique marine mammal veterinary expertise to help fill critical veterinary data gaps that are desperately needed for some of these species. And we need those data gaps filled as early as possible to try to prevent further extinctions like the Yangtze River dolphin. And one of the ways that we do this is by practicing cutting edge care and medicine with animals that are in human care in different settings, and then applying that knowledge that's gained to help at-risk populations in the wild. And the work that we're going to share with you today is an excellent example of how ex situ efforts can help in situ efforts. And for this example, we're going to talk about Deepwater Horizon oil spill that occurred in 2010, as I mentioned, in Louisiana. And following that spill, Dr. Smith, as well as our colleague, Dr. Lori Schwacke, were called upon to lead the investigation into figuring out what the impacts of DWH were specifically on the health of bottlenose dolphins that were living in the footprint of the oil and the huge catastrophe that had occurred. The dolphins were included in NOAA's Natural Resource Damage Assessment, which is a process that is aimed at quantifying the injury that occurs, and then is helpful for determining the appropriate type and amount of restoration that's needed to offset the negative effects of the oil spill. As you can imagine, this was a tremendous undertaking, but now over a decade later, these efforts have resulted in a wealth of knowledge that hopefully will help guide oil spill response, prevention, and policy worldwide. I would like to highlight Dr. Lori Schwacke, Terry Rolls, and Katie Colgrove, who all also co-led the investigations that are being presented today, and would also like to acknowledge the tremendous efforts of the collaborative veterinary and scientific team that represented more than 12 organizations, including nonprofits, government agencies, veterinary hospitals, zoologic societies, and academic institutions. All right, and I think now I will turn it over to Dr. Smith, who's going to set the stage and walk us through the response and the work that followed.
Thanks, Forrest. And hi, everyone. Forrest, can you hear me okay?
I can hear you.
Okay, excellent. Oh, I can't hear you, but that's okay. I think we're good.
I'm here.
Okay. Wonderful. Okay. All right. Thanks. Thanks, Forrest. And thanks so much to Dave and the Marine Mammal Care Center for inviting us. And thanks to all of you that tuned in tonight for your interest in dolphin conservation. So we'll get back to the story now. And what you're looking at are those just devastating pictures that are probably seared in the brains of many of us of the Deepwater Horizon oil spill. And back when it happened in April of 2010, it was that explosion, the collapse of the rig, and then the subsequent flow of oil that resulted in the release of millions of barrels of oil into the northern Gulf of Mexico that really characterized this disaster. So oil then spread to more than 1,000 miles of the Gulf Coast, from western Louisiana to the Florida Panhandle. Next slide. So the surface oil footprint overlapped with the known ranges of 21 species of dolphins and whales in the northern Gulf of Mexico. And 1,000 animals were actually seen, documented, swimming through the oil, and there was no evidence of avoidance. So these animals were swimming through, breathing in the toxic fumes of the oil, and those were the ones that were just documented. So it is thought that thousands of animals were actually directly exposed to the oil. Next slide. Hundreds of scientific studies have been conducted as part of NOAA's Natural Resource Damage Assessment, and the studies were aimed at determining the appropriate type and amount of restoration that would be needed to offset the negative effects of the oil spill. Wildlife studies have focused on multiple species, including shellfish, corals, birds, sea turtles, fish, and the subject for tonight, marine mammals. Next slide. So as a result of the damage assessment, if we fast forward through it, the adverse health effects were well documented in dolphins that were impacted by the oil spill. And these effects included poor body condition or weight loss, lung disease, adrenal system injury, which is the organ system that helps us respond appropriately to stress, and perinatal loss, which means a loss of late-term fetuses, full-term babies, and newborns. So today we're going to really focus on the reproductive losses that were documented in the wake of the spill. Next slide. So following the spill, a high rate of reproductive failure was documented in bottlenose dolphins, and specifically findings from both live and dead animal studies. So studies done where we, and we'll walk through those live animal studies where we could actually evaluate their health, and the stranded animal side, which you are all very familiar with. So the recovery of carcasses, and then the in-depth investigations into those animal recoveries. The findings from both the live and the dead animal studies confirmed a very low reproductive success rate. And it was only 20% of the pregnancies in the heavily oiled estuaries in the wake of the spill were successful. And this is compared to throughout the Southeast region and even along the Eastern seaboard. There have been multiple studies done to look at reproductive success rates. And on average, it's about 67% is what you would expect in a dolphin population with multiple different types of stressors. But when you add in oil, or when you compare it to an oil impacted population, we were down at 20%, which is alarming. Next slide. So the potential causes included poor maternal health, so just simply sick moms as a result of being exposed to the oil. And we know that dolphins were sick with conditions like moderate to severe lung disease, and as I mentioned, the adrenal gland injury, which results in an impaired stress response. And we also considered things like an increased susceptibility to infection. So dolphins that were exposed to oil were seen to have immune system alterations. So this could lead to an increased susceptibility to infection, which can put a pregnancy at risk. And then we also considered that there could be a direct effect of oil exposure on a developing fetus or even the reproductive organs of a female dolphin. Next slide. So our question really was, why were these dolphin pregnancies failing? And how do we get to the bottom of such a complex question? So at the time, we knew we didn't have the tools and techniques needed to answer the question. So the primary objective of the project we're going to be talking about tonight was to advance our methods for evaluating dolphin fetal, placental, and maternal health. And then once those techniques were created, to apply them to investigate the potential mechanism of reproductive failure in those wild dolphins that were exposed to the oil. Next slide. So it's going to start to get a little complicated, and Forrest and I are going to do our best to explain as we go. So please jot down your questions just in case we don't break it down quite to the level that we need to. But we're going to walk through our research approach. And so our first step was to develop innovative methods to really investigate fetal and maternal health. So we're talking about the baby and the mom's health in a well-studied managed dolphin population. And then next, to then apply those enhanced methods that we created to the wild Barataria Bay dolphins impacted by oil and evaluate their fetal, placental, and maternal health. And that's not easy. So we're going to talk through how we did that. And then finally, we would assess the potential mechanism and timing of these pregnancy failures by going back and looking at data from archived cases from managed dolphin perinatal losses. So when pregnancies have failed, when we actually had a lot of data that we could collect, what can we learn from those that help shine a light on these wild dolphin cases? So we'll start at the top and walk through the development of the new methods first. Next slide. The technique that we focused on the most, really, and what we're going to focus most of this presentation now from here on out, is reproductive ultrasound. And if there are, I saw several people that I'm glad to see joined us tonight. And if you know me, if you know Forrest, you know how much we love ultrasound. And you're going to get to see some images of reproductive ultrasound as we really focus on advancing these techniques. And we also looked at, sorry, yeah, there you go. We also looked at developing maternal oxygenation status and blood-based indicators, which we'll touch on, but we're really going to dive deep into the reproductive ultrasound portion of enhancing our ability to evaluate dolphin pregnancies. So I'm going to turn it back over to Forrest, and she's going to keep telling the story.
Thank you. All right, so as Cynthia said, we're going to try not to lose you as we explain how we did this. And as she mentioned, we started by working to enhance our reproductive ultrasound techniques by working with animals that were living in managed care, because this is where extensive health histories are known. So we had a lot of information about the females, the dams, the mothers, as well as previous pregnancies, blood work. All of that information was tangible, and we could have it to help figure out what was going on. And they also get regular pregnancy monitoring. And so the access allows us to really collect the data that's needed, and also to have time with animals to figure out how to enhance these techniques so that we could then take them out into the wild. So to do this, we selected 16 pregnancies in human care of known successful outcomes, and then 22 pregnancies of failed outcomes. And this altogether included review of 517 ultrasound exams, which is a lot of scans. And in each of those scans, we evaluated more than 70 parameters for most of them. So as a result of this effort, we were able to establish a standardized technique for each trimester of pregnancy. So what was to be expected by trimester? This was not necessarily known for all of these ultrasound parameters previous. And we were able to publish an illustrated guide for evaluating both the fetus and the placenta in utero by trimester. And these beautiful illustrations show the fetus in the first, second, and third trimesters. They were drawn by my colleague and friend, Veronica Sendejas, And they really show how that fetus grows over time and is positioned within the female. We further refined techniques for evaluating fetal growth as well. Again, in order to figure out what was going on in the wild, we needed to know what to expect, what is normal for fetal growth. And this included looking at the skull diameter of the fetus, which allows us to calculate estimated due dates, just as is done in humans. And if you look at the image on the left, that's a 3D CT reconstruction of a dolphin skull, and that's showing the plane in which we're measuring the diameter of the skull. The other two images are ultrasound images of dolphin fetal skull measurements. And I'm actually going to take a second to walk through and orient you, because if you haven't seen ultrasound before, it can just look like a bunch of shapes and shades of gray. So just real quickly, because we're going to look at quite a bit of it coming up. This middle image, if you go from the top of it to the bottom, you're moving from the outside of the dolphin to the inside, and each image represents a very thin slice of tissue. The middle image is showing a cross section through the fetal skull, which is that white circle, with the dotted line, which is measuring the diameter. And then if you go to the image on the right, again, working from the top of the image to the bottom, that white layer at the top is the female's blubber layer. And then as you work down, you're moving through the muscle layers and into the uterus of the animal, and then to the dolphin fetus, where you can see the skull, again, with the yellow dotted line measuring the diameter, as well as the chest cavity and the ribs. We also added other measures of fetal growth to our assessment, including changes in the thoracic or chest cavity over time. And you can see that in these ultrasound images in between the white arrows. On the left, what you're looking at is a fetus straight on. So that black circle in between the arrows is the heart. And then moving to the left of the image, you're moving down the fetus into the abdomen. And so we found that you could actually measure the thorax or the chest over time throughout the pregnancy to help figure out what normal growth should be. We did the same with aortic diameter, and we're able to determine normal measurements for the aorta, the fetal aorta over the pregnancy. And then we looked at over 60 parameters altogether, and including the thickness of the placenta. So we had to figure out what normal fetal growth would look like, which is what I just walked through. And then we also knew that we really needed to pay attention to the uterus and the placenta. They lie together in what's called the uteroplacental unit, or UPU for short, is what we refer to it as. And again, it's simply that outer circle around the fetus in Veronica's drawing, that uterus shape is actually the uterus with the placenta laid on top. And we look at that because it's such a vital organ. So even though it's very thin, on average between 2 to 4 millimeters, real thin, it's essential for providing the fetus with what it needs through pregnancy. So we knew if we were having fetal loss and pregnancy failure, most likely we were going to find things wrong with the placenta. But at the time, we didn't know what to expect throughout the pregnancy. How thick should that placenta be in the first, second, and third trimester? How thick should it be in different locations within the uterus? And so we established a standardized technique, which you can see on the right in those ultrasound images, where we measured this UPU in 3 locations over time and figured out basically what normal is. So for those of you that would like more or interested, we have published the normal pregnancy and ultrasound findings associated with normal pregnancy in this publication in the Journal of Veterinary Radiology and Ultrasound, and this year we'll be publishing the abnormal. So our next step, what did we do next? Our next step was to then take these techniques that we had established with healthy pregnancies and apply it to the unhealthy failed pregnancies from managed care, where we had a lot of data and we could figure out what was going on. And then take that, of course, to the wild cases in the oil spill footprint. We evaluated altogether 22 reproductive failures over a 24-year period, and we were able to detect fetal placental abnormalities as early as the first trimester. It's important to note that reproductive failures are not that common in managed care. So it was actually hard to get this data set And that's why it spans over 24 years and required cases from multiple different institutions. The most common ultrasound finding in our reproductive failure cases, as we kind of expected, was the uteroplacental unit, the UPU, where we diagnosed an abnormal appearance in 81% of these failed pregnancies. You can see again the normal looking UPU on the left and how different that uteroplacental unit looks on the right. This was connected with all kinds of causes of reproductive failure, including maternal illness, placental dysfunction, congenital abnormalities, and we were able to confirm that with histopath findings from the recovered placenta, looking at the tissue, as well as on occasion the fetus or the neonate if it was recovered. We also found abnormally thick UPUs. Again, it's pretty obvious, even if you're not trained in ultrasound, how different these UPUs are. On the left, it's nice and flat and thin, and on the right, it's thick and inflamed. And in fact, this is a case of placentitis, or an infected placenta caused by the bacteria Brucella. And this one measures over 1 centimeter. So if you remember, the normal healthy one is between 2 to 4 millimeters. So much larger. And this was something that was quite common in our failure cases. We also found large corpus luteum, which we call CLs for short, in 45% of our failure cases. And the corpus luteum is a structure that's normally found on the ovary during pregnancies, and it's formed at the site of ovulation. And they secrete hormones to help support pregnancy. So why are we seeing abnormally large ones in these failure cases, or some of them? We're actually not sure yet, and we're currently working with some specialists to try to figure this out. It's quite a conundrum, but we're wondering if it's because the placentas are failing and the CLs, the corpus luteums, are kind of overcompensating. We also found maternal peritoneal effusion, which is just a fancy word for free fluid in the abdomen, in quite a few of these cases, 21%. And this really wasn't that unexpected, because when dolphins get sick, they often will put fluid in places it shouldn't be in their body. And so since so many of these dams or mothers were sick, it wasn't unexpected to see this free fluid in the abdomen. Kind of glitching, I apologize. We also did see some abnormal umbilical cord coiling. On the left, you can see what a normal umbilical cord looks like going into the abdomen of the fetus. And this one on the left, I apologize, it's not playing well, but if you can catch it where that arrow is, it's a coiled cord, which is abnormal. And then this slide is a little bit overwhelming, but I just wanted to quickly show it to kind of give you an idea of all the data that we collected for these failure cases, because we had it. This isn't data that you can collect on wild animals or animals that are even in care for a short time, such as at a rehab facility. This is a tremendous longitudinal data set of the dam's life history, and then the pregnancy's life history, basically. Everything from blood work to ultrasound, the history of the mom, and we pulled all of this information together and paired it with tissue analysis of the fetuses or the placentas that were aborted, and we were able to then figure out what the most common causes of pregnancy failure are in bottlenose dolphins, at least in this data set, and then the most common causes of these unfortunate fetal losses. And what we found was that maternal illness was unequivocally the most important underlying cause of pregnancy failure, diagnosed in 68% of the cases overall. We also did see placental dysfunction, as well as congenital malformation. So to wrap this portion of the study up on the managed care animals, the takeaway is that we were able to develop advanced ultrasound techniques that would have been difficult or impossible to develop without access to them for pregnant dolphins, and detect fetal, placental, and maternal abnormalities as early as the first trimester. And this really helped us elucidate what these potential causes of failure were. And this brings us to the next step in our approach, which is to apply these methods in the field in Barataria Bay to then try to figure out what's going on there. So I am now going to transition back to you, Cynthia.
Okay, thanks, Forrest. All right, so now we're going to the wild. So once the protocol and indicators were established with dolphins in human care, we can move on to the wild dolphins living within the oil spill footprint. So those dolphins impacted by the spill. And during capture release health assessments, which are where we temporarily capture wild dolphins for about up to an hour, and I'll walk you through what we do during that assessment and then release them. We were able to examine 44 pregnant dolphins, and this was over a multi-year period, 2011 to 2018, because there's no way to tell easily from just sighting a dolphin whether it's pregnant or not. We do have ways in terms of knowing the dolphin, in terms of photo ID studies, and who they're with, of making some hopefully pretty smart assumptions, but it's tricky. So we had to do our best, and we ended up being able to examine 44 pregnant dolphins. Next slide. So to safely examine wild dolphins, the team that we bring must have extensive experience in handling and evaluating animals. So we bring along marine mammal care specialists, biologists, and veterinarians. Next slide. The live animal health assessments are a really valuable tool that allows us to perform comprehensive physical exams. And these exams include diagnostic ultrasound, which really, within the course of just about 10 minutes, we can do a full body assessment and very quickly have a snapshot of that animal's overall health and internal organ health. And we also collect weight and length, part of the morphometric evaluation of the animal. We collect blood and run several blood-based tests to understand the health of all the different organ systems. And then we can also collect biological samples. So we use this comprehensive approach to evaluating animal health and really applied it to these pregnant dolphins, because it's not the pregnancy itself. If you just looked at the pregnancy, you would miss the full picture. So we needed to wrap those pregnancies with all the other health information that we could to try to get at this question of why were the pregnancies failing. Next slide. So once, when we have the animal in hand, we really quickly know if it's pregnant. Because of the ultrasound examination, as soon as you put that probe on the animal, it just takes about 30 seconds to know, is she pregnant or not? So once we have diagnosed a pregnancy, then over the months to follow, we then go back to figure out if that pregnancy was actually successful. So our field team performs boat-based reproductive surveys, and they time them carefully with our expected due date. So Forrest showed you how we measure those, the skull diameter, and the skull diameter we then plug into our algorithm that then spits out an expected due date. So we have a really good idea of when these babies are going to be born, just based on that single moment in time when we evaluated the pregnancy. So a pregnancy is then deemed either successful or a failure based on when we go back and find that female, whether or not we can also find a newborn. And we take it out quite a bit of time to make sure we don't miss a baby in case she was late and her pregnancy went a little bit longer than expected. We keep looking and so it takes quite a bit for us to actually characterize something as a failure. And of the 44 dolphin pregnancies that we detected, only seven of them actually we could not determine whether there was a failure or a success. And this was because the animal could not be found again. Many of those animals we actually believe to have died, unfortunately. Of the 37 that we could find again, 28 of those pregnancies failed and 9 were successful. So then now we have our pregnancy outcome, and we're still in a bad situation in terms of the outcomes, but we're still trying to figure out, okay, why did we have such a high failure rate? Next slide. So the most common abnormality that we diagnosed based on all of that data and now our enhanced techniques that we're using, specifically the ultrasound data, is that there was an abnormal utero-placental unit, that UPU that Forrest so well described. And when we compared the prevalence of the abnormal UPU appearances between the failed and successful pregnancies, the difference was significant. And more than half of the pregnancies that failed in the wild had an abnormal UPU. So as clinicians, we really start to hone in on these changes in the placenta, which is proving to be an important piece of the puzzle. Next slide. So in fact, in 64% of the pregnant Barataria Bay dolphins that had a failure, there was ultrasound evidence of placental dysfunction. And as early as the first trimester, and that's what really surprised us. We weren't sure if we were going to be able to detect abnormalities as early as the first trimester, but we were. And this was compared, the 64% of the dolphins with failures that had placental dysfunction was compared to only 13% of the successful pregnancies. So there can be some level of placental abnormalities, but for this one in particular, it was much more common in the failure cases. Next slide. So there was another piece of ultrasound data that I'll just give you, I won't spend too much time on, but I'll just share with you to kind of show you the quality of the information that we can get from these very quick ultrasound exams, is looking at fetal pulmonary health. So the health of the lungs inside of this developing fetus is something that we worked with our radiologist, Dr. Marina Ivanchich, to develop. So we based this on a human technique, and we were able to compare the brightness of the lungs versus the liver, and actually use a quantitative measure by measuring basically the intensity in a box, the mean pixel intensity, and comparing it between the lung and the liver. And again, this is a technique that is used in human medicine. So we were able, in all those healthy pregnancies, in the managed dolphin care set, we're able to come up with what should that ratio look like? What's a normal lung to liver brightness ratio? And so then, next slide, once we had figured out what a normal ratio was, we could start to look for that same ratio in wild dolphins, and then very specifically look at them in the failure cases. So this is an example of an abnormal lung to liver ratio. And the image on the left is our normal again, just so you can see that how bright the lungs versus the liver should be. And on the right, you can see there isn't much of a difference between the liver, which you can see there, the arrow is pointing to the liver. It's a little bit darker than the lungs, which are being pointed at on the right, but there's not much of a contrast between the two. And when we actually did the quantitative measure, the ratio was only 1.45, which in the healthy pregnancies was about 2.5. So it's possible that this was pointing toward fetal distress, fetal pneumonia, the types of things that were being diagnosed in dead fetuses and dead newborns that were washing up in the wake of the oil spill. So this was an important additional piece of information where we could start to piece together the timeline of failure and what exactly was going wrong. Next slide. So in addition to ultrasound, we also evaluated maternal oxygenation status. So how well was the female oxygenated, and we were looking at exhaled gases to determine this, and pairing that with blood oxygenation status. And we did document acid-base imbalances. So there is a concern that these acid-base imbalances, which is likely coming from the lung disease that I described before, now you add on a pregnancy, and these acid-base imbalances can become a problem for the developing fetus. Next slide. We also evaluated blood-based indicators. And so what can we tell from a blood sample that can help us understand whether the pregnancy is going to be successful or not? And we looked very carefully at the blood values from the managed animals data set, which Ashley Barrett-Clough led for us and published a couple papers on looking at the differences between successful and failed pregnancies and what can we detect just from a blood sample alone. So we were actually able to make some interesting conclusions from this data set. Next slide. So we found when we were looking at the blood data that and then applied it to the Barataria Bay wild dolphins, that there were actually the same indicators that we saw in managed care dolphins of failed pregnancy. The same ones were popping up in the wild dolphins. So we were seeing that anemia or low hemoglobin count and indicators of inflammation were both correlating with reproductive failure. And we also were able to tie it into then the overall comprehensive health evaluation of that pregnancy. It was just one more piece of the puzzle as we were trying to pull it all together to understand what exactly was going wrong. Next slide. So the third and final prong of our approach was to assess the potential mechanisms and timing of the Barataria Bay dolphin failures by looking at these archived cases from managed dolphin pregnancy losses. Next slide. And the final step of this whole process was just really to integrate all the data together. The ultrasound, the comprehensive health data from the live managed dolphins, from the wild Barataria Bay dolphins, from successful, from failed pregnancies, and then also from this archive data set of known cases of failure to really help elucidate the mechanisms and cause of failure. So I hope this demonstrates like how complex these issues are and these questions are, how much data, how much of a broad approach can be needed to really understand why pregnancies are failing, particularly in a wild animal. Next slide. So our key findings from this long, comprehensive investigation were that 96%, almost all of the pregnant Barataria Bay dolphins, these wild dolphins that had reproductive failure, also had evidence of maternal illness. So these are sick moms. And you know, it's not terribly surprising when you think about the whole picture. These are animals that were impacted by the oil spill. We documented adverse health impacts and then the reproductive issues on top of that. So that's compared to about 25% of the animals that had a successful outcome were deemed to be ill. And then when you look at the mechanisms, we really start to hone in on the placenta problem and the placental dysfunction. So about 65% of the pregnant dolphins that had a negative outcome had evidence of placental dysfunction. And again, as early as the first trimester of pregnancy, which is really remarkable. That is something that was happening so early on and could be detected so early on. And we do, based on all the data as we're pulling it together, we do think that pulmonary disease or this lung disease that the animals have developed is likely contributing to those acid-base imbalances, and that could be having a negative impact on the developing fetuses and creating potentially low oxygen within those fetuses as well. Next slide. So in conclusion, we'll wrap it up here pretty quick and then open it up to questions. We are still seeing a sustained high reproductive failure rate in Barataria Bay, which was the heaviest oiled bay post Deepwater Horizon oil spill. And we are still not seeing, more than 10 years later, still not seeing evidence of recovery. And we've documented these chronic health issues within the oil spill footprint, and we're just not seeing evidence of not just the reproductive failure recovery, but we're not seeing evidence of recovery overall. So it's essential that we continue to monitor these animals, both the live animals, but also from the stranding network side of the house, the animals that wash up on the beach. We need to continue to look at all the information that we can gather to see how long is this going to last, and is it going to be passed on from generation to generation, or is this it? Was it a one-time big hit to the population and now potentially not passed on? So we need to answer that question. And then finally, these compromised populations are vulnerable to additional stressors. So when we're thinking about how to restore the environment for the populations that live there, we need to think about all of the other things that are challenging these animals from a health standpoint. Next slide. So, we've talked a lot about deep water, and just to pull it back a little bit more local and close to home as we wrap this up, we're trying to learn everything we can from this investigation and everything the dolphins have to teach us about the way that animals and cetaceans in particular are impacted by oil. And we now know some of the long-term health concerns for dolphins impacted by oil spills. And they happen all over the place. It's not just in the Gulf of Mexico. And as you here on the West Coast know, they're happening in California. And so we are part of, as well as the Marine Mammal Care Center, the Oiled Wildlife Care Network, OWCN, which is responsible for preparing for oil spills and then responding to them. So we bring all of this scientific, veterinary, medical expertise that we can to oil spills to really make sure that we are understanding the situation and the risk to the different wildlife populations, and then doing what we can to prevent adverse health effects, and then when they do occur, restoring the population back to health. Next slide. So the next step for us as an organization is that we're really incorporating all this oil spill science too into our global operations. So we do have a project called Operation Grace, the global rescue of at-risk cetaceans and ecosystems, and we're leveraging our veterinary and conservation medicine team expertise, and we're aiming to apply all of this knowledge, all of the techniques we developed through the Deepwater Horizon investigation, and incorporate it into our large-scale approach to catastrophes that are happening with wildlife impacted by oil all around the world. Next slide. So just maybe to kick off the Q&A, and if Forrest wants to pop back on, to just kick off the Q&A, one of the most common questions that we get after a presentation like this, which can be pretty jarring, and it's can be, you can really start to go down a pretty sad path. We really all are looking for ways that we can help. So we get that question a lot. Well, how can I help? So if you're here tonight, you're already on the right path, right? So we have this collaboration between the Marine Mammal Care Center and the National Marine Mammal Foundation. So you're probably already doing the things that maybe some of the other parts of the general public aren't. So you're here, you're getting more information, you're learning about the animals that we all care about, you're figuring out how to get more involved, and you're doing those everyday actions that we know can help protect the planet and the animals. So the question for all of you is really, what more can you be doing? So I just would encourage you on behalf of myself and Forrest and our organizations to just keep diving deep into the issues and keep learning everything you can about the animals. And if you're a student and you're here listening in, what career path in science is inspiring to you, that might be calling you so that you can help us with these kinds of problems. Or maybe you're considering a career change or a second career. And so it's never too late to get involved and put your unique expertise and your passion to work for the planet. And finally, our organizations are nonprofits, the Marine Mammal Care Center, the National Marine Mammal Foundation. We rely on public support. So for those of you that can give, we really hope you consider supporting our conservation programs. We need you, we appreciate you, and that's just another way you can help us and make a real difference. So thank you, and I'll turn it back over to Forrest and Dave.
Awesome. Thank you so much, Forrest and Cynthia, for that presentation. And at this point, we'll open it up to questions. I think as people are gathering their thoughts and formulating their questions, but you can put into the chat. I have a question for you all as well. So I wanted just to clarify really quickly, to get a little bit more into the mechanisms, if you know them, from what I heard, and maybe you can help me if I heard wrong, but that the interaction between the oil and the animals, are we thinking that it's through the lungs and some sort of lung interaction and decrease in oxygen from the lungs that then is translated into how the fetus is developing and growing inside of mom? Or did I capture that? Is that kind of the conclusion that you guys came to?
Yeah, that's a great question, Dave. And this presentation could have been like 10 hours long because there's so many pieces. And you just hit on a really important one that we did not actually include, which is how is the oil getting into the animal? So there's multiple ways that we believe it's happening. One is through the respiratory system. So they're breathing in toxic fumes. And then also when they, when dolphins surface in whales and porpoises, they break the surface of the water. And then there's spray that comes up and there's droplets. So we also believe they're inhaling in or aspirating in those oil droplets. It's my dog at the door telling me to come let him join the party. Sorry about that. And so we think they're getting it in through their respiratory tract, through the toxic fumes, through the oil droplets. We think they're getting it in through contaminated prey. So fish that have been contaminated by oil, and then potentially through their skin, although we don't worry quite as much about that. And then also dolphins do drink small amounts of water each day. They consume it, ingest it, through, so they could also just be getting it through contaminated water as they're swimming through oil. So there's multiple ways that we think they're getting exposed. Forrest, would you add anything to that?
No, I think you covered it. It's a good question.
And then however the oil gets in there, the various components within the oil get into the animal, is that then depressing the immune system of mom and then translating that to baby and then leading to those secondary infections that you guys saw in your ultrasounds?
Yeah, it's possible. Forrest, you want to talk about Sylvain's work, or you want me to give it a try?
Try.
Okay, there's a really great set of studies, and they're complicated, by Dr. Sylvain de Guise at the University of Connecticut. And he's been studying the immune system response to the oil spill. And so he's detected immune system alterations. They're it's not just a simple, one immunoglobulin goes up and another goes down. He's looking at cytokine profiles, all these different changes that are happening. And the conclusion that he came to is that the oil spill created, in simple terms for us non-immunologists, basically a hole in the immune system that has allowed things to come in. And that's his thought process. And so things like Brucella, for example, might be able to get in easier to the animal's body, and they're less able to mount a proper immune response and fight off these things that they should be able to fight off. And so the immune system is certainly a part of it. It's just, like I said, it's complex. And so we're looking at incorporating that in. But overall, it's, we have unhealthy females trying to have babies and trying to care for their young. And until these females recover, or unfortunately maybe don't and die off, it's going to be a long road to recovery. And so that's the really sad outcome of this, is that we're finding that it's a sick mom, it's a sick dolphin problem.
I would figure for fairly long-lived animals, we still need to better understand the long-term impacts and of what may happen with those animals that were impacted during that time.
Right.
We had a question from Frank Cipriano. Can you use ultrasound to detect parasite infestations in those animals? Anyways, he's done the same thing with dusky dolphins.
Okay, Forrest, your turn.
Okay, fine. I'll take this one. Frank, hi, Frank. Nice to see your picture and hear from you. We can detect parasite infestations definitely with ultrasound, and in multiple locations. We often see it in the lungs because we are always paying very close attention to lungs during ultrasound and cetaceans because their respiratory system is so unique and important to their health. And so we very easily can detect it in the lungs and also in different areas as well, such as gastrointestinal parasite infestations. So yes, ultrasound's amazing. Depending on where they are, we can probably find them.
We have another question. What biological samples did you gather and what information were you able to obtain? And were there any other helpful blood results besides hemoglobin?
You go, Forrest. I'll fill in anything that, yeah.
We can also call on Ashley here, who's on wrote the blood papers. If you're referring to the wild, which I'm assuming, we collect during that valuable time with the animal, which again is about 45 minutes or so. We collect a wealth of information, everything from blood work from when they're immediately handled to blood work throughout. We take a quick blubber biopsy that gives us skin and blubber. We can look for toxins in the blubber. We do blow or respiratory samples. We do the quick 10-minute ultrasound that Cynthia described, which gives us all kinds of information. And then we collect, honestly, for the blood, we collect tubes and tubes to analyze all different sorts of things from, like I mentioned, contaminants to hormones to indicators of stress. What am I forgetting? What else do we do?
In the beginning of the spill, we also collected urine because we were looking for evidence of the oil and occasionally feces. And then we also did this breath condensate collection where we had this, UC Davis came with us and was collecting droplets that they exhaled, freezing them, and then looking for evidence of oil exposure. And so I think, there's a lot of things you can do. I think what I'll say, as I think is an important message to take away, is we don't collect a sample if we don't think it's going to help us answer a specific question. So there's no excess sampling, and that's important. So like as we went, we said, well, you know what, urine's not really helping us. So we stopped collecting it. Feces isn't really helping us. The breath condensate, we have questions. So we really focused on the samples, taking the samples from the animals that were going to help the species and the population and answer all these big questions. So I think that's just an important thing that I'll add.
So I want to jump in really quick and early on in this talk, you guys mentioned two terms, ex situ and in situ, and I'm wondering if you can help us kind of define those terms. Forrest, do you want to jump in first?
Sure. Yeah, we throw those terms around and we really should spend some time explaining what it means, because I think it's a really important distinction, and an important part of what we're focusing on right now is the integration of the work that's done in these two settings in order to maximize our conservation impact, if that makes sense. And what in situ is work that's done in the environment with wild animals or wild animal habitats to try to figure out what's going on with the species in question. So the biologists that you see, out on the boats doing the field studies, doing the behavior studies, this is super important work. Or the conservationists that are working on policy with the habitat, critical. Then there are folks that are working in ex situ environments. And I do like to define ex situ specifically because I think people often jump to zoos and aquariums and they assume that ex situ means keeping animals in a zoo setting, and it doesn't necessarily. There's a huge spectrum of what ex situ means, which means simply when an animal comes into human care. So that could be for an hour in a rehab setting, or on the beach with stranded, you're able to collect a couple samples and get the animal back into the water. For that time when people are caring for the animal, that's technically ex situ. There's also sanctuary settings, in situ sanctuary settings that kind of become ex situ if they are controlled at all, if that makes sense. And then the far end of the spectrum, of course, is the zoo or the aquarium where captive breeding programs are going on. And the terrestrial and avian communities have kind of been doing this integrated approach for quite a while, where there is a term that we use called the one plan approach. And the best example that I feel like people are most familiar with of a successful one plan approach integrated conservation program where ex situ and in situ work together to save a species that a lot of folks are familiar with is the California condor. And it was really where everyone showed up at the table together, worked together at the brink of extinction to bring this bird back. And so we're really trying to learn from those experiences and with birds and terrestrial animals and apply this one plan approach in the marine mammal community, because we have a lot of, just speaking specifically about small cetaceans, a lot of small cetaceans that are in dire need of help. And it is time for these communities to come together and not work in our individual vacuums, but come together. And we work with Dave and Frank, a few people on the call today, in a group called ICPC, which is an integrative conservation planning for small cetacean. And that's simply our goal, to break the barriers, bring everyone together, because we all respect and need the work that each other are doing in order to really have an impact. I could talk about that forever, but hopefully that summed it up.
I think that was wonderful. Thank you. Cynthia, do you want to add anything?
Not to that. That was fantastic. Well said, Forrest.
Agreed. And we have Barbara Taylor, who will be joining us on March 10th to talk to us a little bit about the vaquita porpoise. And that's sort of where Frank, Forrest, Cynthia, we all met to engage in conservation for that particular animal. And so we'll learn a little bit more about that particular species and sort of where that's taken us. But I think it's a really important discussion to be had amongst the conservation community, that we broaden our idea for making sure we include all of the tools available in the tool chest to apply towards conservation success. Especially given your first slide, Cynthia, with up to 1 million animals that are at the brink of extinction and an emergent extinction of species in marine and ocean environments, which is lagging slightly behind or significantly behind land environments in the number of species that are being impacted today. So these are critical issues, and it's something that we really need to consider and move forward on. All right, well, it looks like we may not have any more questions today. So I want to say thank you both, Dr. Smith, Dr. Gomez, thank you so much for joining us for this talk tonight. It was really wonderful to hear from you guys and to add all of this information about something I know we all were so glued to so many years ago, and it's important that we not forget those impacts are still lasting.
Yeah, that's right. Thank you. Thanks again for having us and for helping us to do that and remind everyone of the impact and really think about how we can do better in the future.
All right, thanks everybody. Thanks for joining us, and we hope you join us again on our next Beneath the Surface lecture series with Marine Mammal Care Center. Thank you so much.
Thank you.
Thank you. Bye.